The star Betelgeuse, a red, extremely enormous beast tracked down in the heavenly constellation of Orion, has long enchanted stargazers and cosmologists alike due to its sheer size and brilliance. If Betelgeuse were placed where our Sun is, it would extend to the orbit of Jupiter, certifying its giant size. Notwithstanding being situated around 642 light-years from Earth, its immense size makes it one of the brightest stars visible to the naked eye. Recently, Betelgeuse has shown unusual behavior, such as surprising dimming and brightening cycles, which many scientists believe signal that the star is nearing the end of its life. The popular physicist Brian Cox recently made a striking statement that Betelgeuse is on the verge of a massive explosion, expected to happen within the next 2 weeks. This event, known as a supernova, will mark the end of Betelgeuse's life. However, it will provide a remarkable opportunity for scientists to study one of the most extraordinary and powerful phenomena in the universe. As a red supergiant, Betelgeuse is classified as one of the largest and most massive types of stars. It has been on the galactic radar for decades, but its recent unpredictable fluctuations in brightness have sparked speculation that it is preparing for a supernova. When a star like Betelgeuse reaches the end of its life, its core collapses under its own gravity, leading to a massive explosion that releases an enormous amount of energy, radiation, and cosmic material into space. Betelgeuse's imminent explosion is expected to be a Type II supernova, a specific kind of stellar explosion that occurs when the core of a massive star collapses. This core collapse triggers the release of neutrinos and radiation, creating a shock wave that tears the star apart. The explosion will be so bright that it may be visible from Earth without telescopes, possibly even outshining the moon in the night sky for weeks or months. While such an event would typically be catastrophic if it occurred close to Earth, Betelgeuse's distance of around 642 light-years means that, although the explosion will be spectacular and dramatic, it poses no danger to life on our planet. However, the event promises to reshape our understanding of supernovae and cosmic phenomena. A supernova is one of the most powerful events in the universe, releasing more energy in a few seconds than the Sun will produce in its entire lifetime. Betelgeuse's explosion will not only be an extraordinary cosmic display, but also a significant moment for science. Scientists are eager to observe this rare event from its earliest moments using a variety of ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to collect as much data as possible. When Betelgeuse explodes, it will emit a broad range of radiation, from visible light to gamma rays. One of the most significant aspects of the supernova will be the surge of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually reach Earth before the light from the explosion due to their ability to travel through almost everything without being affected. Observatories like Japan's Super Kamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, providing an early signal of Betelgeuse's final moments. The explosion will also provide crucial insights into the formation of heavy elements. When stars explode, they produce and distribute elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will give scientists a clearer view of this element formation process, which is critical for understanding the formation of planets and the chemistry of the universe. While Betelgeuse's supernova is not expected to have harmful effects on Earth, it will interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst from the explosion, specifically the emission of cosmic rays and charged particles, could result in more intense auroras, expanding the regions where the northern and southern lights are visible. Although these cosmic rays could affect satellite communications and some technologies on Earth, the disruptions are expected to be minor and temporary. Perhaps one of the most exciting aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For weeks or even months, Betelgeuse is expected to be the brightest object in the night sky, possibly even visible during the daytime. This spectacle will captivate not only the scientific community, but also amateur astronomers and the general public, sparking renewed interest in astronomy and the universe. Scientists have long speculated about Betelgeuse's fate, but Brian Cox's recent statement adds urgency. Observatories worldwide are preparing to monitor every phase of the supernova, and the data collected will be crucial, potentially transforming our understanding of stellar evolution, supernovae, and the distribution of heavy matter in the universe. Betelgeuse's supernova will allow researchers to refine their models of cosmic distances. Being relatively close to Earth, it offers a unique opportunity to measure how energy from such an explosion travels through space. By observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust between stars, astronomers will gain a clearer understanding of the universe's scale. The event will also provide a once-in-a-lifetime opportunity to investigate dark matter and its potential influence on the structure of the universe. Dark matter, the mysterious substance that makes up around 85% of the universe's mass, does not emit or absorb light, making it difficult to detect. However, observing how light and matter behave around Betelgeuse after its explosion could provide indirect clues about the role dark matter plays in the universe's large-scale structure. Betelgeuse's supernova will also bring us closer to understanding the life cycles of stars, particularly how massive stars contribute to the formation of elements essential for life. Supernovae are the key cosmic events responsible for spreading heavy elements throughout the universe, elements that ultimately form new stars, planets, and even living organisms. By studying Betelgeuse, scientists will gain valuable insights into how these elements are created and distributed. The cultural significance of Betelgeuse's explosion is also noteworthy. For centuries, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most prominent stars in the Orion constellation will prompt philosophical reflection on the transient nature of the universe. In some cultures, such celestial events have been interpreted as omens or signs of great change. Betelgeuse's explosion may inspire a mix of awe, fear, and wonder as people from all walks of life witness the death of a star. This grand event is likely to reignite interest in space exploration and astronomy, drawing more people into the pursuit of knowledge about the universe. Amateur astronomers are already preparing for the event, as modern technology allows almost anyone with a camera or telescope to observe and document the supernova. This democratization of science will unite people across the globe, all watching and recording the same massive phenomenon from their unique vantage points. It looks like the original text has already covered a lot about Betelgeuse's impending supernova, its scientific significance, and its cultural impact. However, if you'd like me to continue, I can expand on related topics such as 1. What happens after Betelgeuse's supernova? The formation of a neutron star or a black hole. The dispersal of elements into space and how they contribute to new star systems. 2. How astronomers will study the explosion in real time. The role of major observatories like JWST, Hubble, and neutrino detectors. How amateur astronomers can contribute to observations. 3. The impact on future space exploration and technology. How studying supernovae helps scientists refine space travel and planetary formation theories. Possible links between supernovae and the search for habitable exoplanets. For Betelgeuse in mythology and historical astronomy. How ancient civilizations viewed the Orion constellation. Predictions and myths about star explosions in different cultures. One fascinating theory is that dim matter exists as pitifully interfacing monstrous particles, weaklings. If weaklings exist, their cooperation with the energy produced by Betelgeuse's cosmic explosion could provide insights into their nature. Such a revelation would be a noteworthy contribution. The first immediate proof of dark matter, a tricky peculiarity that has confounded researchers for quite a long time. Besides, there is potential for Betelgeuse's impact to offer insights into the nature of dark energy. Dark energy is the baffling power driving the accelerated expansion of the universe. Understanding its role in astronomical advancement is one of the most critical challenges in modern physics. Betelgeuse's explosion could provide indirect evidence of dark energy's effect on stellar death, as supernovae are believed to be influenced by the universe's expansion. Observing how Betelgeuse's cosmic explosion propagates through space could provide key data to help researchers understand how dark energy affects cosmic events and influences the universe's large-scale structure. As Betelgeuse's explosion moves closer, the scientific community is preparing for one of the most anticipated astronomical events of the century. The blast will offer a unique opportunity to observe the final stages of a massive star, providing insights that may have implications far beyond our current understanding of stellar life cycles. While scientists anticipate the dramatic spectacle of the supernova, they are also refining methods to study the aftermath of such a blast. One area of focus is the formation of a neutron star or possibly a black hole in the remnants of Betelgeuse. A neutron star is the dense core left behind after a massive star like Betelgeuse undergoes a supernova. These compact objects, which can have a mass greater than that of the Sun packed into a sphere no larger than a city, are a major area of study in astronomy. If Betelgeuse forms a neutron star, it will provide a significant opportunity to study the behavior of matter under extreme conditions. Neutron stars are also known to generate intense magnetic fields and are sometimes observed as pulsars, emitting regular beams of radiation. The formation of such a stellar remnant could offer crucial clues about the fundamental physics of extreme gravity and the behavior of matter at extraordinarily high densities. If Betelgeuse instead collapses into a black hole, it would be another major breakthrough for scientists studying the formation of these enigmatic objects. Black holes, regions in space where gravity is so strong that not even light can escape, have been the subject of fascination and theoretical exploration for decades. Observing the formation of a black hole from a relatively nearby star, like Betelgeuse, will help scientists refine their models of black hole creation and better understand the role they play in the universe. Additionally, it could provide new ways to observe the mysterious event horizon, the boundary beyond which not even light can escape, shedding more light on the nature of black holes. Another significant consideration is how Betelgeuse's explosion will contribute to our understanding of cosmic rays. These high-energy particles, produced in events like supernovae, can travel vast distances across the universe. While some cosmic rays are detected by observatories on Earth, others have been difficult to study due to their unpredictable nature. When Betelgeuse explodes, its supernova will generate a massive amount of high-energy particles, giving scientists an opportunity to study cosmic rays in real time. This could enhance our understanding of how cosmic rays interact with the interstellar medium and how they may impact space travel and technological systems on Earth. Moreover, the supernova will serve as a stellar laboratory for the study of neutrinos. As mentioned earlier, neutrinos are notoriously difficult to detect because they rarely interact with matter. However, they carry valuable information about the processes occurring deep within stars. By measuring the flux and energy of neutrinos from Betelgeuse's explosion, researchers can gain a clearer understanding of the mechanisms behind the star's collapse and the formation of heavy elements like gold and uranium. This could improve our knowledge of nucleosynthesis, the process by which elements are created in stars and distributed throughout the universe. Beyond its scientific significance, Betelgeuse's supernova will likely have a major cultural impact. People around the world will have the rare and inspiring opportunity to witness a spectacular celestial event, reigniting interest in space exploration and the mysteries of the universe. The event will serve as a reminder of the vast scale and grandeur of the cosmos, inspiring future generations of astronomers, scientists, and explorers to continue seeking answers to the fundamental questions of existence. As Betelgeuse approaches the final stages of its life, its impending explosion is expected to expand our understanding of the universe's fundamental processes. One area where this event could offer new insights is in the study of gravitational waves. These ripples in space-time, predicted by Einstein's theory of general relativity, are generated by massive cosmic events such as the collapse of a star into a black hole. While gravitational waves have been detected from events like colliding black holes, Betelgeuse's supernova could provide a new opportunity to observe waves generated by the core collapse of a massive star. Detecting these gravitational waves would provide researchers with valuable data on the structure of space-time and the nature of the event itself. The supernova could also help refine current models of how elements are distributed throughout the universe. When massive stars like Betelgeuse explode, they scatter elements into space, enriching the interstellar medium with the building blocks essential for life. This process, known as stellar enrichment, plays a crucial role in the formation of new stars, planets, and other celestial bodies. By studying the aftermath of Betelgeuse's explosion, astronomers will be able to map the distribution of these elements across the cosmos and gain a better understanding of the recycling of matter that drives cosmic evolution.